Today we're going to talk about the properties of solutions. So in the solution formation, it's the composition of the solvent and the solute that determine whether a substance will dissolve or not. So before we get more into things that will affect this, we need to know what a solvent is and what a solute is. Okay, so the solute is what is going into or what's being dissolved. Think of it as it's going into the solution. The solvent is generally what you have most of. And I remember that because solvent is a longer word. There's more letters in solvent than there are in solute. So for the most part, solvent is what I have more of. Water is your universal solvent. When you're dealing with this. So an example of solvent and solute, let's say that we are making, we're putting a Crystal Light packet in our bottled water. So the actual Crystal Light packet would be our solute because that's going into it, and it's being dissolved into our solvent. Our solvent would be our bottled water. So that's solvent and solute. So there are things that we can do to determine how fast it will dissolve. You'll remember some of these things when we talked about the factors that affect reaction rate, but this is for solubility. So those things are agitation, which is just simply to stir. Going back to the adding Crystal Light in our bottled water, when we do that, we shake the bottle up. So that's agitation. Temperature, we can increase temperature if we're making sweet tea. Generally speaking, we add the sugar to the sweet tea when it is hot because an increase in temperature will cause the sugar to dissolve faster. And surface area, we talked about this in reaction rate. Granulated sugar is going to dissolve faster than sugar cubes, and that's dealing with surface area. So in solubility, what solubility is it's the amount of solute, there's that word again, that dissolves in a given quantity of solvent at a specific temperature and pressure. And solubility is often expressed in grams of solute per 100 grams of solvent. So when we say something is soluble, it's just talking about it's able to dissolve. A solute is able to dissolve an amount of solvent. So in solutions, there are three types of solutions that we can have. There's saturated, unsaturated, and supersaturated. Okay, so saturated is a solution containing the maximum amount of solute that can be dissolved. Unsaturated, there is more solute that can be dissolved. And supersaturated, a solution has more solute than dissolved it is saturated. And I'm going to show you an image that will make a little bit more sense. So in these examples, if you notice on the far left, we have our unsaturated solution. More solute dissolves. So it is think of the name if we are the prefix un. It is under, so I need more of it. Are saturated, no more solute dissolved. Think of this as like your happy medium. It's the perfect amount. Supersaturated, the prefix super is going above and beyond. So I have so much that at the bottom I've got added crystals growing. And going back to that, if we were thinking about one of my favorite labs to do, and I wish that we were able to do this, but one of my favorite labs to do is a Kool-Aid lab where we make different types of Kool-Aids. We make an unsaturated, a saturated, and a supersaturated. So think of it in terms of Kool-Aid. We've all had Kool-Aid. If we were to make an unsaturated solution, that would be watered down. If we were looking at, like, for example, fruit punch, it would have a pinkish color because we had more solvent, which would be water, than the actual sugar. Saturated would be like the happy medium. It would be the perfect amount following the recipe. Super saturated, we would have way more powder or the sugar than we should. And so it may seem a little gritty or granulated. We could feel the texture in that. So those can help you with understanding those types of solutions. So in liquid mixtures, we have two types. We have miscible and immiscible. A miscible mixture is that the liquids will mix evenly and they form a homogeneous solution, which homo just means the same. So it's the same throughout. So if, I don't know why you would want to do this, but if you were to mix soda or Coke with Kool-Aid and you agitated it, you stirred it, it would be the same throughout. You couldn't see where the Coke starts and ends and where the Kool-Aid stops. It is a homogeneous mixture, so that is miscible. An immiscible mixture is when liquids do not mix evenly and they form what's called a heterogeneous mixture, which means different. So you can clearly see the difference between the two. A very common example is mixing oil with water. If you do that, you can shake it up all day long, but as soon as you stop, it will separate and you can see the distinction between the water and the oil. So, and going back, looking at one more time at the solutions, the saturated, unsaturated, supersaturated. Remember, saturated has as much solute as the solvent can be dissolved. So this is like your happy medium. Unsaturated, it's underdeveloped. Think of it like that. It doesn't have enough solute. We need to add more. So it's going to seem weak, so to speak. And supersaturated, it's above what we have. We have too much solute, and it's going to seem way too strong. In terms of the language that you might see, this would be very concentrated, and this would be diluted. So knowing those will help as well. So looking at those factors again, we talked about temperature, pressure for gases only if we're talking about gases, particle size, so like the surface area. We talked about the granulated sugar versus the sugar cube, agitation or stirring, and concentration, which is what we looked at. If we have something with very little solute in it, it's going to dissolve quickly. Or if we have something with a lot of solute, it's going to take a while to dissolve. So thinking about our Kool-Aid, if we were to make Kool-Aid super saturated, meaning we had more solute than solvent, so I had a lot of the sugar, it's going to take a while to dissolve all that in versus if we only added a little bit of sugar to the water. So that is properties of solutions. I hope you found that helpful. And we will look next to solubility curves.